Whether or not humankind's written history is a simple blip of 10 or 5 seconds in the amazing plan of the universe, one thing is clear: the universe is a motherlode of old miracles. What's more, interminable motivation moves our look to our vast lawn the smooth way. There's an enthralling, inestimable tango at play. Later estimations hint that stars on the edges of our cosmic system are swaggering their stuff in sluggish movement, contrasted with their partners in other universes. What's the astronomical scoop? Well, there are a few theories, and one murmurs that our Milky Way may be low on an imperceptible vast fixing called dark matter. The subtle substance impacts the gravitational dance of divine items. There's an infinite puzzle involving dark matter, the strange substance we can't see, but that appears to play a gravitational pull of battle in the universe. One chance shaking our inestimable comprehension is that perhaps we've been seeing dark matter the wrong way. Our enormous compass may be pointing off course. Here's where the European Space Agency's Gaia satellite strides into the vast spotlight. It's like our inestimable analyst, giving many-sided insights about the dance of almost 2 billion stars in our Milky Way. Consider it a cosmic movement example. The satellite's exact estimations have led astronomers to reevaluate their vast movement notes. Stars at the outer edges of our Milky Way appear to be taking it slow, testing our old presumptions about their speeds. Now, how does a star's speed spill the grandiose beans about a system's weight? It's like checking the size of a group by how quickly people are moving. Cosmologists, equipped with Gaia's data, estimated the combined load of our galaxy's gas, dust, stars, and that tricky dark matter to be around 200 billion times our Sun. It seems like a vast heavyweight, but here's the unexpected development: it's around 5 times less than we figured. One hypothesis to unravel this infinite question suggests we could have been a bit ponderous with our dark matter estimates. Perhaps, quite possibly, there's less dark matter out there than we previously expected. It's like finding out there are fewer ingredients in your vast soup than you thought. However, hang on, measuring a galaxy is like trying to accomplish something patently impossible, famously precarious. The Gaia data could have a few peculiarities, or our infinite measuring tape could require some changes. Still, numerous research groups have joined the celestial examination, and they all seem to be murmuring the same grandiose tune. If this infinite disclosure holds, it's like opening a new chapter in our grandiose physics textbook, an upheaval that could make us reevaluate not just our own Milky Way, but every ritzy corner of the universe. As Stacy McCord, a space expert at Case Western Reserve University, puts it, this could be a grandiose game-changer. Take a journey back to the 1970s when cosmologist Vera Rubin and her inestimable team set out on a celestial adventure. Their mission, studying how stars move in other galaxies. The grandiose playbook suggested that stars on the edges of a galaxy should be grandiose dawdlers compared to the zippy stars near the center. Here's where the unexpected developments came in. Rubin and her stargazing crew uncovered a grandiose shock: stars at the farthest reaches of galaxies were swaggering their stuff at almost the same speed as those closer to the galactic dance floor. Imagine a cosmic disco where everybody, regardless of where they are, is moving to the same beat. This grandiose disclosure alluded to the presence of something baffling and hidden: dark matter, the invisible heavyweight champion that forms these massive halos around galaxies. Now, focusing in on our galactic patio, the Milky Way, imagine trying to track everything in your room while being inside it. Tricky, right? Cosmologists faced a similar celestial challenge, assuming that Milky Way stars played by the same rules as those in other galaxies. For instance, our Sun, dwelling around 26,000 light-years from the cosmic heart, orbits at about 800,000 kilometers per hour. The Gaia satellite, launched in 2013, acts as our precision astronomical ruler, measuring the positions and movements of Milky Way stars in 3 dimensions. The data it's been sending back resembles an enormous orchestra, slowly refining its accuracy over time. The theoretical physicist Francesco Cini and his astronomical investigators from the Enrico Fermi Study and Research Center in Italy detected subtle traces of a celestial slowdown a few years ago, and with Gaia's most recent data drop in 2022, these hints became enormous fireworks. The new data is twice as precise as the data from 2018. Astronomers now employ advanced instruments to track star movements with laser accuracy, reaching cosmic distances that were once a bit fuzzy in the heavenly theater. In 2023, isolated research papers disclosed a divine shock. Stars up to an incredible 100,000 light-years from the Milky Way's heart appear to be moving slowly. It's as if the stars are stirring things up around the town in a Clarion downfall reminiscent of the planetary dance Johann Kepler described hundreds of years ago. Meanwhile, in other cosmic systems, stars generally follow a similar cadence, moving from the center to the outer edges at comparable speeds. It's a grandiose movement orchestrated by the gravitational force of dark matter. However, the Milky Way seems to be the agitator artist in this astronomical ball. No other galaxy has shown this specific slowdown, as noted by France Sledge from the Paris Observatory. This astronomical disclosure isn't just stirring up our heavenly dance floor, it's challenging a key astronomical standard. Cosmology ordinarily says no place in the universe is more special than another. Yet, with its celestial slowdown, the Milky Way may be wearing the grandiose crown now. Early cosmic math suggested our Milky Way was a heavyweight, boasting a mass of around 200 billion suns. Yet, here's the twist, later recalculations put it at a huge 200 billion solar masses. Astronomers are quite sure of their apparent material estimations around 60 billion solar masses. Doing the math, if the two figures hold, it paints an infinite picture where the dark matter to normal matter ratio is just 2.3 to 1. That's undeniably less than the astronomical norm found in galaxies of comparable size. Still, some scientists think there might be something else entirely to this celestial slowdown story. It's like reading a book and discovering there's an unwritten chapter waiting to be found. The Milky Way may be holding more grandiose secrets than we've uncovered so far. They've been exploring the cosmic unknown with the Gaia satellite, our space Sherlock Holmes, offering high-accuracy insights about stars up to a certain cosmic distance. However, there's a twist beyond Gaia's reach, a grandiose magnifying glass wilderness ready to be explored. Researchers believe the celestial show could veer off in unexpected directions. Astrophysicist Lena N.B. from MIT, one of the inestimable investigators, suggests that stars farther out, beyond Gaia's cosmic handle, may be arranging their heavenly speed show. It's like an intergalactic enigma. Difficult exercise, assuming a few stars are easing back down, others may be firing up in the enormous race. Lena N.B. suspects that the astronomical show could have more shocks up its heavenly sleeve to add grandiose flavor to the blend. There's the baffling huge Magellanic Cloud, a cosmic buddy circling the smooth strategy for getting around 160,000 light-years away. This inestimable companion is acting as anticipated, moving to the tunes of standard dark matter models at a stunning pace of more than 650,000 miles per hour. It resembles a dependable vast dancer, following the widespread steps. Then there are heavenly REM, the divine reverberations of more modest universes and star bunches that got altogether too near our smooth way and wound up destroyed by its gravitational ability. These heavenly streams paint a cosmic picture in accordance with the powerful approximations, adding one more layer to the inestimable secret. Whether or not mankind's written history is a simple blip of 10 or 5 seconds in the grand plan of the universe, one thing is clear: the universe is a goldmine of antiquated wonders and interminable motivation. Shift our look to our vast patio, the smooth way. There's a dazzling enormous tango at play. Later estimations hint that stars on the edges of our galaxy are swaggering their stuff in sluggish motion, contrasted with their partners in other universes. What's the enormous scoop? Well, there are several hypotheses, and one murmurs that our smooth way might be coming up short on an imperceptible astronomical fixing called dark matter. The slippery substance impacts the gravitational dance of heavenly objects. There's an infinite riddle involving dark matter, the puzzling substance we can't see, but that appears to play a gravitational tug-of-war in the universe. One possibility shaking our astronomical understanding is that perhaps we've been seeing dark matter the wrong way. Our grandiose compass may point off course. Here's where the European Space Agency's Gaia satellite steps into the enormous spotlight. It's like our vast detective, giving unpredictable insights concerning the dance of almost 2 billion stars in our smooth way. Consider it a cosmic movement example. The satellite's precise estimations have driven space experts to reconsider their infinite movement notes. Stars at the outer edges of our smooth way appear to be moving slowly, testing our old assumptions about their speeds. Now, how do star speeds spill the inestimable beans about a universe's weight? It's like checking the size of a crowd by how fast the individuals are moving. Stargazers, armed with Gaia's data, estimated the combined weight of our universe's gas, dust, stars, and that elusive dark matter to be around 200 billion times our Sun. It seems like an inestimable heavyweight. However, here's the unexpected development: it's around 5 times less than we previously thought. One hypothesis to unravel this inestimable puzzle suggests we may have been a bit heavy-handed with our dark matter estimates. Perhaps, just perhaps, there's less dark matter out there than we previously believed. It's like figuring out there are fewer ingredients in your grandiose soup than you thought. But hang on, gauging a galaxy is like nailing jelly to a wall. Famously tricky. The Gaia data could have a few quirks, or our astronomical measuring tape might need some adjustments. Still, various research groups have joined the heavenly investigation, and they all seem to be humming the same infinite tune. If this vast discovery holds, it's like opening a new chapter in our enormous physics textbook, an upheaval that might make us reevaluate not just our own smooth way, but every elegant corner of the universe. As Stacy McGaugh, a cosmologist at Case Western Reserve University, puts it, this could be an inestimable game-changer. Take an infinite journey back to the 1970s, when space expert Vera Rubin and her inestimable team set out on a heavenly adventure. Their mission? Studying how stars score in other galaxies. Now, the astronomical playbook suggested that stars on the edges of a galaxy ought to be inestimable slackers compared to the zippy stars near the center. Here's where the unexpected twist came: Rubin and her stargazing crew uncovered an inestimable surprise. Stars at the most distant reaches of galaxies were swaggering their stuff at nearly the same speed as the ones closer to the vast dance floor. Imagine a cosmic disco where everyone, no matter where they are, is moving to the same beat. This grandiose discovery alluded to the presence of something baffling and hidden: dark matter, the invisible heavyweight champion that forms these enormous halos around galaxies. Now, zooming in on our vast lawn, the smooth way, imagine trying to keep tabs on everything in your room while being inside it. Tricky, right? Stargazers faced a similar infinite challenge, assuming that the smooth way stars played by the same rules as those in other galaxies. For example, our Sun, living around 26,000 light-years from the galactic heart, spins around at 800,000 kilometers per hour. The Gaia satellite, launched in 2013, resembles our precision vast ruler, measuring the positions and sweet moves of smooth way stars in 3 dimensions. The data it's been sending back is like an enormous orchestra, bit by bit refining its precision over time. Theoretical physicist Francesco Cini and his inestimable analysts from the Enrico Fermi Study and Research Center in Italy saw subtle traces of a heavenly slowdown a few years back. With Gaia's latest data drop in 2022, these hints became inestimable fireworks. The new data is twice as precise as the data from 2018. Cosmologists now use improved tools to track star parts with laser precision, reaching infinite distances that were once a bit fuzzy. In the Heavenly Theater of 2023, 4 independent research papers have uncovered a divine shock: stars up to an incredible 100,000 light-years from the smooth way's heart seem to be moving slowly. It's like the stars are hitting a clarion downfall, reminiscent of the planetary orbits Johannes Kepler described centuries ago. In the meantime, in other cosmic stories, stars, by and large, follow a comparable musicality, moving from the middle to the external edges at tandem-out velocities. It's an inestimable movement coordinated by the gravitational draw of dark matter. Be that as it may, hang on, the Milky Way is by all means the revolutionary artist in this vast ball. No other galaxy has shown this specific logjam, brought up by Franz Mallet from the Paris Observatory. This astronomical discovery isn't simply stirring up our heavenly dance floor, it's defying a major cosmic principle. Cosmology typically says no spot in the universe is more exceptional than another. Anyway, the Milky Way, with its heavenly logjam, may be wearing the vast crown now. Prior, infinite math recommended our Milky Way was a heavyweight, boasting a mass around 200 billion suns. Yet here's the twist, later recalculations put it at a huge 200 billion solar masses. Astronomers are quite certain about their apparent material estimations, around 60 billion solar masses. Doing the math, if the two figures hold water, it paints a massive picture where the dark matter to conventional matter proportion is simply 2.3 to 1. That is undeniably not quite the universal norm found in galaxies of comparative height. Anyway, a few specialists think there may be another side to this heavenly lol story. It's like reading a book and sensing there's an unwritten part waiting to be discovered. The Milky Way may be holding more vast mysteries than we've revealed up to this point. They've been looking into the cosmic obscure with the Gaia satellite, our space Sherlock Holmes, offering high-accuracy insights about stars up to a certain vast distance. Yet, there's a bend past Gaia's vast reach, there's an infinite magnifying glass at the outskirts ready to be investigated. Researchers trust the heavenly show could go off in an unexpected direction. Astrophysicist Lena N.B. from MIT, one of the leading researchers, suggests that stars further away, past Gaia's enormous handle, may be adjusting their heavenly speed show. It's like an intergalactic difficult exercise, if some stars are slowing down, others may be speeding up in the vast race. Lena and others suspect the cosmic show could have more shocks up its divine sleeve to add astronomical flavor to the mix. There's the confounding Large Magellanic Cloud, a cosmic companion circling the Milky Way from about 160,000 light-years away. This vast companion is acting similarly to what is expected, moving to the tunes of standard dark matter models at a stunning pace of over 650,000 miles per hour. It resembles a solid cosmic artist following the universal advances. Then there are cosmic remnants, the divine reverberations of smaller galaxies and star clusters that got too close to our Milky Way and ended up being destroyed by its gravitational ability. These cosmic streams paint a vast picture in line with the weighty approximation, adding another layer to the cosmic mystery. Anyway, in the Grand Analyst office, wariness is a guiding star. Astronomer Robin Sanderson from the University of Pennsylvania makes virtual Milky Ways on a computer, simulating what Gaia could see. She points out that these cosmic plots depend on certain assumptions, like the shape of the Milky Way's dark matter contribution, which could influence the outcomes. She encourages caution in making strong determinations from the current cosmic clues. The story doesn't end here. Our cosmic voyagers are preparing for future missions. The Vera Rubin Observatory, with its full-spectrum eyes set on the stars, may unfurl additional heavenly insights from the Milky Way's external reaches. Gaia, the cosmic witness, designs a fabulous uncover in late 2025, furnished with even more exact data. In our astronomical mission, specialist Sledge is eager to examine other galaxies and see if their stars slow down like in our Milky Way. It's like exploring space neighborhoods for a similar cosmic show. This investigation is a normal part of science, a bit like assembling a puzzle where patience is key. The universe is like a tremendous library of secrets, from our nearby solar system to the farthest cosmic corners. Imagine ancient cosmologists scratching their heads over comets and stars, those were the cosmic riddles of the past. Despite our innovative instruments, like computers and space observatories, we're still cosmic investigators with about 95% of the universe enveloped in mystery. At the point when we analyze the universe's edge, we start with the detectable universe. It's like looking through a window into the scope. The detectable universe includes everything we can now recognize, measure, and examine with our telescopes and space missions. It is an assortment of stars, systems, and heavenly bodies that are apparent to us. The difference is that the noticeable universe is only a part of the entirety. Consider it a small piece of a massive pie that people can study and see. However, the general size and structure of the universe remain a secret.